So in this podcast, we're going to look at galvanic cells, and galvanic cells are essentially how a battery works. And galvanic cells, here we go, galvanic cells. They're also known as voltaic cells, after Alexandra Volta, which is where we get our unit, the volt. But essentially, we're just going to draw a picture. I'd like you to draw the picture with me. So, we might have some beaker or glass or something, and it's kind of just here. We're going to have a piece of metal in this glass. And here's the rest of our glass. Boop, boop. And we have another glass. And we have the metal going this way on this one. Alright, kind of something like that. Okay, and let's say this metal is zinc. We're going to say that this metal is copper. Okay? Additionally, we're going to have some liquid in here. And this liquid has zinc ions. So it might be, if we think back to solubility rules from first semester, maybe it's zinc nitrate, because nitrates are always soluble, maybe zinc chloride, but something. So the anion is not important, but no, there are some anions floating around, so there's some negative charge, but it doesn't matter. Similarly, over here, we have got some copper ions floating around. And again, it might be nitrate, chloride, bromide, something that's soluble with copper. Alright, so we might hook a voltmeter up. So I'm just going to have our voltmeter, or our multimeter, and our voltmeter. It's right up here, and it has two wires that maybe clip onto our pieces of metal, kind of like that. And that is kind of what it looks like. And the next thing we're going to do is we're going to go look at our goldenrod sheet, and we just want to look real briefly where copper and zinc are. So notice copper's right here, so it is above zinc. Alright? So we know that copper's reaction is going to look something like this. I'll just right over here. Copper plus 2 electrons yields copper metal. Alright, so copper is being reduced, which means it's gaining electrons. Over here on this side, it's going to be the opposite, because zinc was below copper. So we have zinc metal going into zinc ions plus 2 electrons. How come? Because zinc is being oxidized, or it's losing electrons. So real quick, what happens is, when we hook this up, our zinc metal, this metal rod, starts dissolving, for lack of a better word, and it introduces more zinc ions into our solution. Alright? So more zinc. The electrons that are right here flow through this wire. So we have 2 electrons moving, and they go through the voltmeter, give us a voltage, and those 2 electrons come over here. And what happens? These 2 electrons meet up with some of the copper ions floating around, and actually combine to make more copper solid. So as this reaction proceeds, the mass of this metal gets lower. Alright? So mass, we're just going to say decreases, where the mass of our copper increases. Okay? So batteries eventually wear out because one thing is the anode, one thing is the cathode, and it actually runs out, and there's no more electrons that can move. So if we hook this up in class, nothing would actually happen. Alright? And there's a reason for that. So what has to happen is we have to have what's called a salt bridge. So a salt bridge is simply something that we introduce that goes into both of our beakers, and it has some solution. A really great solution is sodium nitrate. Alright, and when it dissolves, we really have sodium ions and nitrate ions. Okay? Alright, so what happens is, on our left side, because zinc is turning into zinc ions, this beaker is becoming positively charged. Okay? How come? Because originally we have the same number of zinc ions as we have anions, and it's kind of neutral. But as soon as zinc starts getting put into here from our zinc metal, it becomes more positive than it should. Similarly, over here on this side, because copper is leaving and it's a plus charge, we have anions floating all around in here. So originally they cancel each other out, but as these pluses leave, this becomes kind of too negative. So the salt bridge kind of equilibrates this positive-negative charge that's happening in our two beakers, all right? So that nitrates flow this way, and sodiums flow that way. Alright? So the sodiums make up for this negative charge that's building up, and the nitrates make up for this positive charge building up. Alright, the last thing, and we've had this in a podcast before, but because over here this is being oxidized, this side of our battery is known as the anode. And the easy way to remember that is that oxidize and anode both begin with vowels. Okay? So I can put vowels and underline it. Over here on this side, alright, on our copper side, this is reduction happening, and this is known as our cathode. And every battery has an anode and a cathode. It is the positive and minus sides. And again, just think vowels, cathode begins with a consonant, and reduction begins with a consonant. Anode begins with a vowel, and oxidize begins with a vowel. So again, cathode, you might think consonants, just like anode, think vowels. Alright, and that is what a galvanic cell looks like. Every battery you use has an anode and a cathode, and electrons flow from some metal that's kind of falling apart into another metal that's gaining mass as those electrons are going from one point to the other.